Everybody. It's nice to be back. John Allspaw invited us here because he was using some of our work. And when we came in past years, we said, this isn't about transfer to you. This was about us seeing in you the future. You just heard it, right? How do you keep pace with change? We started talking about hidden and extensive interdependencies and how those would create kinds of complexities that could lead to outages in your business critical services. We started understanding and talking about how as this complexity grows, no one can have an accurate model. Or at least if you have an accurate model, it won't be accurate for very long because things keep changing in this accelerating world that you're fueling as well as responding to. So in that context, talking with some of the people here, we said we really need to pull together a consortium of partners to look at the kinds of complexities and how you deal with them. Snafu is normal. We're not interested in the snafus. We're interested in you because you're snafu catchers. And so we started the Snafu Catcher Consortium with some partners. And we announced it a year ago here. So we're back to tell you what we've done in the last year. We've put together an approach based on looking at you and going out in a project we called Coping with Complexity.
So we start out with this view of what we think of as the world and the system, which is that we've got this code and we've got this stack and we do this stuff to it and that connects up to the using world out there. But in fact, if we call this the system, we miss a whole bunch of stuff. There's connections of this thing. It's not drawn in a bubble. It doesn't mean there's a cloud. It just means that that's the system. There's connections of this thing to a whole bunch of stuff that you use to make that work. You've got code generating tools and testing tools and deploy tools, a whole bunch of stuff that's existing out there that's really part of that. And you could say that this is the system because many of you spend much of your time focused on those things that are not inside that little bubble there. We can take another step forward, and if we do, we'll just sort of divide all of this stuff by a line that we call the line of representation, and now we add in you. The people who are getting stuff ready to be part of the running system, the people who are adding the stuff to the system, they're doing the architecture, they're doing the framing, and they're also keeping track of the system, what it's doing, how it's doing it, what's going on with them. And you'll notice that each one of these people has some sort of mental representation of what that system is, and if you look at it a little more closely, you see that none of them are the same. By the way, that's very characteristic of these worlds. Nobody's got the same representation. If we play this out a little bit further, we end up with something that looks like this. This is our model of the world, and it includes not just the things that are running there, but all of you and the kinds of activities that you are performing, the cognitive work that you are doing to keep that world functioning. And if we play with this a little bit more, we end up with this kind of model. The model has a line of representation going through the middle, and you interact with the world below the line via a set of representations. Your interactions are never with the things themselves. You don't actually change the systems. What you do is you interact with a representation, and that representation is something about what's going on down below. You can think of those green things as the screens that you're looking at during the day, but the only information that you have about the system comes from these representations. And what's significant about that is all the activities that you do, all the observing, the inferring, the anticipating, the planning, the reacting, the modifying, has to be done via those representations. There's a world above the line and a world below the line. And although you and we mostly talk about the world below the line as though it's very real, as though it's very concrete, as though it's something, the thing, in fact, the big surprise is this. You never get to see it. It doesn't exist. In a real sense, there is no below the line that you can actually touch. You never ever see code run. You never ever see the system work. You never actually touch those things. What you do is you manipulate in a kind of, I don't want to call it an imaginary world because it's real, but you manipulate a world you cannot see via a set of representations. And that's why you need to build those mental models, those conceptions, those understandings about what's going on. Those are the things that are driving that manipulation. It's not that world below the line that's doing it. It's your conceptual ability to understand the things that have happened in the past and the things that you're doing now and why you are doing those things, what matters and why what matters matters. Once you adopt this perspective, once you step away from the idea that below the line is the thing you're dealing with and understand that you're really working above the line, all sorts of things change. And what we've done in the project is to try and explore some of those changes, understand what it means to really take the above the line world seriously. This is a big departure from some of the other stuff that you've seen, but it's what we think of as the sort of starting place for the work that we're doing.
So what we did was we asked our partners to take one of their postmortems. We had groups who already did blameless postmortems, inspired a lot by John Allspaw, and we said, okay, take one of those. We sent some of our people to go work with them, to dig into these cases a little further, bring them all together. And we were going to use those cases of successful snafu catching. And then Winter Storm Stella hit, right here in New York, late spring ice storm, so we were all stuck. So we got to work even longer going over the interesting patterns that were present in the cases. There were 3 cases presented, and we looked at how snafu catching played out. Now, what's great about this is we had a bunch of different perspectives, right? The teams from each organization were expert in their system, their world, their technology, their context, their financial or regulatory pressures. We also had shared perspectives overlapping between the different groups. Even though they were different in the details, many of the experiences and technical issues and problems and anomaly characteristics were things that they said, oh, yes, that's happened to me. As if you take the report, which is available now, the link will come up in a little bit, you can read through these cases of snafu catching, and you'll probably experience things like that too. Now, the third part of the sharing and crossing perspectives, trying to make visible what's above the line, right, was the fact that we had people like Richard and myself and some of our team there to help abstract these things out and say, these are related to things we've seen before. But these are also things that create new challenges that we can investigate to improve the way we provide business-critical digital services. Here's a list of a few of these that emerged, and we're going to talk about a couple.
So the first one is, we're going to give you a flavor of is postmortems as recalibration. Why do people do postmortems? Well, there's lots of different reasons, and we go into some of them in the report. But the fundamental reason is to try and recalibrate those mental models so that they cover the right sorts of things and they're well connected to the world that's below the line. That's the function of postmortems. And you can tell that it's working when somebody says, as we often hear in them, I didn't know it worked that way. When somebody says that, what they're saying is, my mental model doesn't correspond with the experiments that I can run below the line, and I'm trying to bring those things back into coherence and correlation. And we see this all the time. There's a whole bunch of other things that flow from this. Don't have time to go into them all. There's a bunch about surprise and representations and hypotheses and how you do other things. It's all in there. But remember that postmortems are things about what happens afterwards. And we will talk some more about ways that you can make your postmortems better and do more interesting things. We have lots and lots of experience in this from other domains and other industries. We're glad to go into it with you.
Well, when I came and visited you and talked, one of the things I mentioned about complex systems was the presence of strange loops. Strange loops comes from Hofstadter way back in 1979. The heart is a strange loop, and of course, your systems have strange loops in them. They are a natural product. They exist, right, as complexity, interdependencies, hidden interdependencies grow. So as the system becomes more complex, some part of that system provides a vital function, which turns out, but that part also depends on the function it provides. The heart is an example. It provides oxygen to vital organs, but the heart's a vital organ. It's all great as long as things are normal. The problem is when things are abnormal, it becomes very difficult. Now, what was interesting in the workshop, the Stella workshop and the report, as you'll see, is that all 3 cases turned out to have strange loop phenomena, dependencies going on that complicated understanding the snafu and responding to it effectively before it became an outage. Now, the way the strange loops appeared in the 3 cases were different. So it's a great example of how bringing together a set and contrasting across this set allows you to see patterns that you wouldn't see otherwise. Now, strange loops also have a very interesting challenge for us in how to help deal with it. So it's a great design and investigation challenge moving forward.
Another theme that we came up with ended up being a kind of a new concept, something we had to build out of scratch, and we ended up calling it dark debt. You all know about technical debt. Well, we're not interested in technical debt. We're interested in dark debt. It takes its name from the idea of dark matter, which is this stuff that holds the universe together. It makes up 95 or 93% of the world, but we can't see it. We have trouble detecting it. And in fact, you have lots of dark debt in your systems. It arises from unforeseen dependencies. It's invisible until the anomalies get revealed. You can't look at it and say, oh, I'm trading off more dark debt today in exchange for getting the thing done faster. It doesn't work that way. It is a product of creeping complexity, and the specific countermeasures that we use to try and defend against it are generally too narrow. Snafus that cascade to failure arise from dark debt. They don't arise from technical debt. Technical debt is about trying to bring your next product to market. Dark debt is trying to keep the system running as it is. And we think dark debt's a really important idea, and we think you spend a lot of time struggling with, worrying about, trying to put your hands around, trying to cope with the consequences of dark debt. And so we want to introduce this term today because we want you to start using it. Whenever you say technical debt, we want you to also say, but there's this dark debt thing that counts for most of the problems that we're having that we're really not addressing very well.
So where does this connect back in, right? The dark debt, to find it, you need, right, good ways to look at snafu catching. You can't wait for things to be bad. You have to understand how you catch snafus and how that triggers the above-the-line recalibration and model updating. So tell us, share, get back to us about the cases that you run into when you start to see dark debt in action, or how you uncovered dark debt, or how you were able to see it and then resolve a situation.
Our site just went down as a consequence of all of the downloads of a big PDF, but we don't really care. It's out there. You can get a hold of it. Please take a look at it, download it, look at it in your leisure, or use it for other purposes. It's pretty straightforward to get a hold of us. We're in there, and we'd like to talk to you. We have 2 other things that are happening today. There's an office hour portion, this thing that's happening at the Velocity conferences where you get to talk one-on-one with the people who are presenters. We're going to have one of those. I'll be there, and David will stop by. Please come if you would like to talk about that. We also have some birds of the feather discussions at lunch today. So if these things are of interest to you and you want to sit down and chat with the people who are doing it, we have John Allspaw here. We have David Lee here. These are the 2 people who provided most of the technical stuff that we're doing. They will be present for lunch, and we would love to be able to have the time to sit with you and chat over a meal about what this all means and how it works. So please do come. Let's start a conversation.
So Snafu Catchers is real. We've got our first product out. We've had a successful first year. We're moving forward, identifying some on that list of 6 items to do projects with our partners. We're trying to expand our partner list, pooling resources to explore these general issues. And we'd also like to announce today that as we've looked at other organizations that aren't DevOps organizations until they had an outage and realized that their usual product, like flying passengers on airplanes or running hospitals, turned out to depend on their DevOps, which they weren't very good at, we've decided that some of these organizations, they're not really going to participate in a pooled, forward-looking, creating foresight kind of R&D effort. They need some help now. So we've launched Adaptive Capacity Labs with John Allspaw, who's joined the Snafu Catchers team. So John is joining us, and we have the pooled R&D exploratory mechanism of Snafu Catchers, and then ability to deliver targeted things to, stand up, John, wave to the crowd.
Hey! The crowd roars its approval.
And so that's how we're moving forward in terms of building on what I thank John and others here for getting us involved with you, because you really do represent the way waves of complexity and change are moving forward. And the lessons we learned from you also apply to many of the other industries I work with.
Thank you.